Billions of years ago, Earth was a very different place from the one we know today. The atmosphere was thick with gases like methane and ammonia, and the air was completely devoid of oxygen. In this alien world, early life forms existed, but they were far simpler and smaller than anything we see today. These life forms were anaerobic, meaning they didn't need oxygen to survive. In fact, oxygen was toxic to them, but something extraordinary was happening in the oceans. A process that would forever change the course of Earth's history and make the world habitable for complex life. This is the story of the Great Oxygenation Event, a turning point that shaped life as we know it. To understand how the Great Oxygenation Event occurred, we need to go back about 2.4 billion years. During this time, the planet was dominated by microorganisms, including a type of bacteria known as cyanobacteria. These organisms were some of the first to perform a revolutionary process called photosynthesis. Photosynthesis allowed cyanobacteria to use sunlight, water, and carbon dioxide to create energy, with oxygen being produced as a byproduct. At first, the oxygen produced by cyanobacteria was absorbed by oceans and rock formations. But as the cyanobacteria multiplied over millions of years, the oxygen they produced began to accumulate in the atmosphere. This accumulation of oxygen was slow, but it was relentless. Over time, it reached a tipping point. What followed was a dramatic change to Earth's atmosphere, a change so significant that it's now known as the Great Oxygenation Event. This was the first time in Earth's history that significant levels of oxygen filled the atmosphere. While oxygen is essential for life today, back then it was a deadly threat to the anaerobic organisms that dominated the planet. Oxygen is highly reactive, and it can be toxic to cells that aren't equipped to deal with it. So, as oxygen levels rose, many of these early life forms couldn't survive in the new environment. This led to one of Earth's first mass extinctions, wiping out countless species of anaerobic organisms. But while this event was catastrophic for some, it opened up new opportunities for other forms of life. The presence of oxygen allowed for the evolution of aerobic organisms, life forms that could use oxygen for respiration. Unlike anaerobic organisms, aerobic organisms could generate much more energy from oxygen, allowing for the development of more complex and efficient cells. This shift to an oxygen-rich atmosphere paved the way for a completely new era of life on Earth. The increased energy efficiency provided by oxygen meant that organisms could grow larger, become more complex, and eventually evolve into the plants and animals we know today. But the Great Oxygenation Event didn't just impact life. It also had a profound effect on Earth's environment. Before the event, the sky likely had a reddish tint due to methane in the atmosphere, and the oceans were green, filled with dissolved iron. As oxygen levels rose, the iron in the oceans began to oxidize, forming rust, which settled at the bottom of the ocean. This process created the banded iron formations that we find in ancient rocks today. In fact, these iron deposits are some of the strongest evidence we have of the Great Oxygenation Event. They serve as geological markers of the time when oxygen started to accumulate in the oceans and eventually spilled into the atmosphere. With the methane in the atmosphere breaking down, Earth's skies eventually turned the blue color we recognize today. The ozone layer, which protects life from harmful ultraviolet radiation, also began to form thanks to the oxygen produced during this event. This was crucial for life's further development, as it allowed organisms to evolve and survive outside of the oceans. So the Great Oxygenation Event wasn't just a turning point for life, it was a transformation of the entire planet. It turned Earth from a hostile, oxygen-free world into a planet capable of supporting complex life. And while it may have been devastating for the early anaerobic organisms, it was essential for the evolution of everything that came after. Without the Great Oxygenation Event, Earth might still be home to only simple, single-celled organisms living in an atmosphere without oxygen. But thanks to the cyanobacteria and their revolutionary process of photosynthesis, life as we know it became possible. The story of Earth's evolution is full of these pivotal moments, and the Great Oxygenation Event was one of the most significant. It's a reminder that even the smallest organisms, like cyanobacteria, can have a massive impact on the world around them. In future videos, we'll explore how life continued to evolve after the Great Oxygenation Event, from the rise of multicellular organisms to the development of more complex life forms. But for now, we can appreciate just how crucial this event was in shaping the planet we call home. Thanks for joining me on this journey through Earth's history. If you enjoyed this video, don't forget to subscribe for more explorations into our planet's past. And be sure to check out our quiz shorts to test your knowledge on Earth's incredible evolution. See you next time.